Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel that we're watching, so my video channel, is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU actuary. Here's the problem for today for exam LTAM. John is planning to retire in exactly 3 years. John's final average salary, used to calculate his pension, is defined as the average salary in the final 2 years of his employment. John's firm awards salary increases at the end of each year. The latest awards have been just announced, and John did not get a raise. John models his salary increases using a two-state Markov model with annual transitions. You are given, in state 0, his salary increase will be 0%. In state 1, his salary increase will be 5%. John is currently in state 0. John's salary in the next year will be $100,000. Probability of transition from state 0 to state 0 is 0.70. Probability of transition from state 0 to state 1 is 0.30. Probability of transition from state 1 to state 0 is 0.60. Probability of transition from state 1 to state 1 is 0.40. Calculate the expected value of John's final average salary. And here's the solution. There are 3 years until John's retirement. In the first of those years, his salary is already determined. It will be $100,000. In the 2 years after that, the final 2 years of his employment before retirement, the following scenarios are possible. State 0 followed by state 0, so no raise and no raise. The probability of that is 0.7 times 0.7, 0.49, and then his final average salary will be the average of 100,000 and 100,000, so that's 100,000. Or state 0 followed by state 1, so no raise followed by 5% raise. The probability of that is 0.7 times 0.3, that's 0.21. And then his final average salary will be 100,000 plus 105,000 divided by 2, and that's 102,500. Or state 1 followed by state 0, which means that he gets a 5% raise and then no raise. The probability of that is 0.3 times 0.6, and that's 0.18. And I apologize, I had a typo here. But his salary after a 5% raise will be 105,000, followed by 105,000 because no raise from 105,000 will give him the last year's salary of 105,000. So the average, the final average salary will be 105,000. And then the fourth possible state is 1-1, which means 5% raise followed by 5% raise. The probability of that is 0.3 times 0.4, 0.12. And his final average salary will be 105,000 from the first year, and then 110,250 from the second year averaged, and that gives us 107,625. Therefore, the expected final salary is each of those possible final average salaries multiplied by its probability. So it will be 0.49 times 100,000 plus 0.21 times 102,500 plus 0.18 times 105,000 plus 0.12 times 107,625, and that gives us the expected value as 102,340, which is answer C. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.